Let's take a look at this example. This one looks very nice. Okay, so how am I supposed to start solving this problem? I would simply redraw this circuit in order to make this looking kind of simple. Okay, so you're supposed to realize that this is going to be my total current. Okay, the meter is going to send the current to the circuit, and this is going to be my I total. Okay, and this point, okay, this node, I'm going to call node A. This node, I'm going to call node B. This node, I'm going to call C. This node, I'm going to call D. This node, I'm going to call E. This node, I'm going to call F. This node, I'm going to call G. And this node I'm going to call H. Okay, and right now I'm going to try to redraw this circle in order to make this looking a little bit simpler. Okay, so this is my point A. My point A, right, is connected to the resistor R1, is connected to resistor R2, and is also connected to the resistor R10. So this is my resistor R1. Okay, point A is also connected to the resistor R2. Point A is also connected to the resistor R10, right? Now, R1, okay, resistor R1 is connected to the resistor R4, okay, and the other side of the resistor R1 is my point C. Okay, this is my point C, and point C is connected to resistor R4, and C is also connected to the resistor R12. Okay, so the other terminal of my resistor R4 is connected to terminal D, and another terminal of resistor R12 is connected to terminal G. Next, I have resistor R2. R2 is connected to point B. This is point B, by the way, and R1, it was point C over here. So B is connected to the resistor R3 and resistor R11. Okay, R3 is connected to point D, and R11 is connected to point F. Okay, so this is what I got. And now this is not RT, this is R10. And R10 is connected to the terminal E. Okay, E, and it goes to the resistor R5. Okay, let me write this away. This is R5 and goes to terminal G, and also is connected, E connects, is connected to R6. So I have over here R6, and this is my terminal F. This is my point F, okay? F. Next, take a look what I have. Next, I have D. This D and this D is the same D. Okay? Okay, so I'm supposed to connect them together. This G and this G is the same G. Okay, I can connect them together. This F and this F is the same F. Okay, please notice that G is connected to resistor R8, G. G is connected to resistor R8 and is connected to the negative terminal, I can say under the other terminal of my meter. Okay, so let me call this as like this is my point H. Okay, this is my point H. Okay, and we have D. D is connected to resistor R13, right? D is connected to resistor R13 and also is connected to H. Okay, and we have also point F, which is connected to resistor R7. This is R7. Okay, and also is connected to H. So now, let's take a look at this circuit. Someone is going to say, this circuit doesn't look easier. But what you're supposed to realize, that total current is not given. If total current is not given, I assume this is just simply my I total. We're supposed to remember that values of resistors, right, are the same. Okay, every resistor has value of 100 ohms. So this current is going to split into 3 currents. But because the values of these resistors are the same, so each resistor is going to have the same current. So this is going to be simply 1/3 of I total. This one is going to be also 1/3 of I total, and this one is going to have also 1/3 of I total. And this current is going to split again into two resistors which have the same value. So each resistor over here is going to have just 1/6 of I total, because 1/3 divided by 2 gives me 1/6. So I have 1/6 and I have 1/6, 1/6, 1/6 and 1/6. And after that, this 1/6 will come together with this 1/6, and I'm going to get again 1/3 over here, 1/3 over here, and 1/3 over here of my I total. Now we're supposed to take a look what happened. I total was divided into 3 currents. Okay, so when the current is divided, it means this is the parallel circuit. And because the values of the currents are the same, 1/3 of my I total, so I have simply parallel circuit over here. So I can simply write that my R total is equal R over N. Okay, so I'm talking about these 3 resistors. Okay, R over N. Why? Because the values of the resistors over here are the same. Okay, they are the same, and these 3 resistors are in parallel. That's why I'm going to use this formula, R over N, plus this time I'm supposed to look at these 6 resistors. Please notice that this time total current has been divided into 6 the same currents. So it means that these 6 resistors are in parallel. So I have again R over N. But let me call this section A, this is section B, and this is section C. Okay, so let me just write this is my RA, this is my RB, and this is my RC. Again, I have 3 resistors. They have the same currents. Okay, 1/3 of I total. So my total current is divided. So it means this is the parallel circuit, and I'm going to call this RC over N. So R total is equal resistance, right, of each resistor in this part of the circuit is equal what? 100 ohms over 3, because I have just 3 resistors in section A, plus RB. every resistor in this section is also having 100 ohms, right? Resistance. And how many resistors we have? We have 6 resistors, so we have over 6. In section C we have again 3 resistors. That's why I'm going to say this is 100 ohms over 3. So our total is equal, I'm supposed to use the calculator, 100 divided by 3 plus 100 divided by 6 plus 100 divided by 3. This is equal 83.33 ohms. Okay, so the total resistance of this circuit is equal 83.33 ohms. The problem is solved.